David Knight. I own a small mechanical engineering company called the Monterey Energy Group, and we'll be giving the webinar today. We'll probably start in about a minute. I guess if you have a question, you can type it in. I'll do my best to answer them as we go. Let's see. I've given this presentation mainly live to about, I don't know, 20 or 30 groups of architects or HVAC contractors, solar contractors. It's much easier to give it live than it is to give a webinar. It's much easier to have that interaction. So I'll do my best. Again, if you have some questions, type them in, and I'll do my best to answer them as we go. Okay, NZEC Certified basically is a consulting company we've started up as a side to our regular mechanical engineering business, and we've worked on about 100 projects in the last year. Homes, not all homes. We've done, we have a couple of jobs for churches, a few school jobs, a couple of small office buildings, but it's mainly homes, and which are engineering companies that we do probably 90% of our work is residential, which is odd for a mechanical engineering company. At any rate, we started this last year, and it started on a house we were doing up in Petaluma, and what basically happened is we just were amazed how good the numbers came in. We were amazed how inexpensive solar electricity had become, and also were encouraged to see some new products coming on the market that made doing a net zero energy house practical and affordable. We define net zero energy as a home that produces as much as much energy as they consume, and we look at not only what's inside the building, lights, appliances, domestic hot water, space heating, and air conditioning, but also what's outside, well pumps, pool filter pumps, outdoor lighting, you name it, we include it all. And that's how we go about working on our net zero energy houses. Again, this presentation covers, for the most part, the 100 projects we've done. Most of those are just now finishing. So we have a couple case studies of houses that have been completed. All right. Basically, what happened in 2009, in my mind, was just nothing sort of amazing. It's kind of a convergence of 4 factors that made doing a net zero energy house practical and affordable. The first, a tremendous reduction in the cost of solar electric systems. In 2007, 2008, most PV contractors were charging about $10 a watt installed pre-incentive. The start of 2009, they were down to about $8 a watt. By the summer of 2009, it was $7 a watt. By the end of 2009, for a decent size, something close to a 10 kilowatt system, they were down to $6 a watt, and we are often getting quotes under $6 a watt. That's pre-incentive. Plus, the systems, not only are they coming down in cost, they're also producing more energy per square foot, making them easier to integrate into the building. 2-3 years ago, to do a 10 kilowatt system would require 1,000 square feet of roof area. Now that same system can be done in about 600 square feet of roof area, making it much easier for space planning. Okay, so the PV story is great. Also, the incentives got better. At the end of 2008, we had a 30% federal tax credit for solar systems for quite a while. At the end of 2008, it became uncapped. Before it was capped at $2,000. Now it's uncapped 30%, which makes a great extra incentive for the system. Thirdly, the overall efficiency of homes, this didn't happen in 2009, but it started to happen. It's been happening for the last 10, 15 years. Homes have become significantly more efficient. Much better windows, better insulation. The appliances are better, the lights are better, the efficiency of the HVAC system is better, the duct loss is less. Everything is better, and it continues to get better. We used to always think, but our company does about 1,000 energy compliance jobs a year and about 400 residential mechanical designs a year. We do them all over the country. And I should also mention we have net zero energy houses in New Jersey, in Florida, Colorado, Alabama. Got a nice job in Hawaii yesterday. These jobs come up, it's not just California where this makes sense. It's actually quite national. At any rate, but, in the old days, we always figured, well, 20, 25 BTUs a square foot were the actual loads after we would, run the numbers. We're seeing most jobs coming in now at about 10, 15 BTUs a square foot. Again, heat loss is much less. And the fourth factor is the introduction of some European and Japanese technology air-to-water heat pumps that are coming on the market. These are devices that use electricity very efficiently to give you warm water for domestic, warm water for space heating, either through floor heating or through fan coils, and also chilled water for cooling. And what makes it nice for the net zero story is because solar electric has gotten so inexpensive, it makes sense to use electricity for space conditioning. And the trick was, well, what electric products? And with these devices coming on the market, it's a very compelling story. At any rate, so on the other side of it, so the results of those four factors, we're looking, most of the systems, we're thinking you're going to see a payback in somewhere between 5 and 7 years. I mean, the payback starts the first month. And when we get to the case studies, you'll see the very first month you're making money. But a simple payback 5 to 7 years, return on investment 15 to 20%. Again, easier building integration because the panels produce more energy per square feet. And the great thing about grid-tie solar electric systems is they're almost zero maintenance. Okay, sorry. The way we do this is, in our consulting is it's two factors. You've got, well, four factors. You've got reduction, and I mean it's the balance of net zero energy is, the more you reduce, the less you have to produce. The greater the reduction in energy, the less amount of energy we need to produce. So basically, we work on the reduction side, and this is being done, automatically. I mean, with the new Tile 24 and good energy consultants around the state, and good engineering practices, you're seeing these things being done anyway. And like I mentioned, the insulation is better. The glazing is significantly better. Most new projects now are going with Energy Star windows, U-value 0.3, SHGC 0.3 or better, have become standard. These things really don't cost any more. Your HVAC numbers are getting better and better, as is the duct losses. We'll talk about lighting and appliances in a little bit. And the other factor that's come up, which is kind of a hassle for most, but it really helps in some ways from the engineering side, is verification. The fact that we have third-party HERS verification required on so many projects where we now know exactly what the infiltration rate is. We know exactly what the duct loss is. Two factors that we basically guessed on in terms of heat loss and heat gain numbers for years. Now that's all being figured out. As well on the verification side is the PV production. If every new house that puts in a grid-tied solar electric system needs a third-party inspector to come in and check to make sure it's not in the shade, it's aimed the right direction, it's the proper inverter, and all the rest. So that's on the reduction